Right, it is function machine time. Okay, and I think the key bit of this question is trying to figure out what it's actually talking about. A number's put into the machine, the output is used as a new input, the second output is 11. Work out the number that was the first input. Well, I'm gonna talk this through slowly. I'm gonna give like an example that it's not gonna give me the right answer, but I'm gonna go for it. So imagine I put in 1, then when I times it by 2, I'd get 2. Then I'd add 5 and I'd get 7. And what the question is saying is that the output is put back into here. So now I'd put in 7. I'd times it by 2, I'd get 14. I'd add 5, I'd get 19. And that would be my second output. And what the question is saying is, well, if it was 19, what if the second output was 19, what would the first input be? It'd be basically saying, how can I calculate 1? And we can see that we basically do the opposite to the function machine. We're actually doing the inverse function. So I would minus 5, I would divide by 2, I put that back in as the first output or second input. I would minus 5 again, divide by 2. So let's do that. Let's ignore me just talking through it slowly and have a go. So I know that the second output is 11, so I'm going to put that in here. And then I'm going to do the opposite, and that's going to give me 6 when I minus 5. And then I'm going to, so this way I'm minusing 5, and this way I'm going to do the opposite again. I'm going to divide by 2, and that's going to give me 3. And that is my my second input, which becomes my first output. Okay, so it's basically going to move to here, and I'm going to do the same again. I'm going to minus 5, which gives me minus 2, and then I'm going to divide through by 2 to give me minus 1, and that is my first input. That is my answer. Okay, part 2. A number's input into the machine, the output given is the same number. Work out the number. Well, I can see that it doesn't work for minus 1, and I can't remember what number I tried at the start, but it didn't work for that one either. What can we do? We can maybe write down a general number and see what happens. So let's say I call my input x now, because that's the thing I want to know, but I don't know what it is. But I do know when I multiply it by 2, well, that's going to give me 2x, and then when I when I add 5, I'm going to get 2x plus 5. That's going to be my general output. That's what's been happening in this function machine up here with the numbers. But now it says the output is the same as the input. So I can create an equation. It must be that x is equal to 2x plus 5. And I've formed and solved an equation. Two ways to do this. Probably like method 1 is like try and get the x's on one side. So you might minus 2x from both sides because the 5 is already on the right hand side, and I'll get minus x equals 5, and then I'd have to either switch it around or imagine timesing or dividing by minus 1. I'm going to get that x is equal to minus 5. That's the answer, and you can check it, you can put it back into the function machine if you like. Second way of doing this, solving this equation, would actually be to minus x from both sides, and you'd get 0 equals x plus 5. And that's absolutely fine. You've just got to remember to have the 0 in there. And now I could minus 5 from both sides, and I'd get exactly the same answer. I just wanted to talk about 2 different ways of solving it. Okay, good. All right, last part. Another function machine is shown below. Now we don't know what's going on, but we're told if the input is 3, the output's 5, and if the input is 7, the output is 25. So let's think about this. I'm going to be timesing by something, and I'm going to be minusing something. Well, I'm not going to use x here because normally we refer to x as the input, and I'm not going to use y because normally we refer to y as the output. So I need to consider something else. So I'm going to imagine I'm timesing by p, and I'm minusing q. These are 2 good unknowns to use, and that's going to help me out because it's going to be, if I put in 3, then I'm going to get, if I times it by p, I'm actually going to get 3p. And if I then minus q, I'm going to get 3p minus q, and I'm told that that is equal to 5. Brilliant. I don't know what p and q are, but at least I've formed an equation, because now I need to use a second piece of information. If I put in 7, then when I put it through the function machine, I'm going to get 7p. When I minus q from it, I'm going to get 7p minus q, and I'm told that that is equal to 25. What I've created are simultaneous equations. I've got 2 unknowns, 2 equations. Now to solve this, I'm going to write them with the larger numbers at the top. You don't have to, but it's going to mean I can see where I'm going with this, because these two are the same sign. What we should do for these sorts of simultaneous equations is minus them. Okay, I can do this left-hand side minus this left-hand side, and it's going to be 4p, and then these cancel out because it's minus q minus minus q. And then I'm going to do 25 minus 5, and that's going to be 20. And p is equal to 5. So I can now, sort of maybe move this out of the way, because it wants me to fill in the boxes, and I can put down times by 5. Okay, what do I do now? I can substitute back in. I'm going to substitute back into the bottom one, so it's going to be 3 times 5 minus q is equal to 5, or 15 minus q equals to 5. And to be honest, easiest way of solving this equation is just to spot what to do, and q is going to be 10. So actually, I'm going to move this out of the way, and I'm going to be minusing 10. Now I've finished basically, but just to say, if you don't like that method of solving simultaneous equations, another way you can do it is it's kind of substitution. It's kind of making something that the subject, the same thing with subject. So I could rearrange this first equation to 7p minus 25 equals q. I've added q to both sides and I've minus 25 from both sides. I could do the same with the bottom one, and it would be 3p minus 5 equals q. And because I'm solving them simultaneously, I'm interested in when they're equal to one another, essentially. When this equals this, it must be that 7p minus 25 equals 3p minus 5. And I could then solve that. I've created an equation with p on both sides, but it's going to give me 4p equals 20 again. And I could solve it from there. I just wanted to mention that as an alternative for the simultaneous equations.